am going to teach about how to write the test bench Verilog HDL code for ring counter. So previous video we discussed the normal Verilog HDL code and operations of ring counter. If you need it, kindly refer the video. Now I am going to write the test bench Verilog HDL code for ring counter. So first you write module, then module name, ring test bench. So ring test bench is the module name. Then declaring the input variables and output variables. I already told input variable declare as register and output variable declare as wire. So in this ring counter we have two input variables, clock and reset, and output variable Q. So reach, clock, reach, reset. Then input variable is Q. So wire 3:0 Q. So first you write module, then write the module name. So here module name is ring TV. Then declaring the input variables and output variables. So input variable is register clock and register reset, and output variable declare as wire. So wire 3:0 Q. Then you write the module name. So while writing the Verilog HDL code, in which name you used in the module name, that name reflect here. Reset. So dot clock, clock is a instantiations declaration, dot reset, reset, dot q, q. Then always 10. So this 10 represent 10 time cycle. So nanosecond or picosecond. So each 10 cycle, time cycle, clock value is equal to naught of clock. So it's a clock signal. So let me assign initially the clock signal value is 0. So after 10 time cycle, naught of clock. Just taking complement 0 to 1. So after 10, it goes to 1 to 0. After 10, this goes to 1. So likewise, it continuously toggle 0 to 1, 0 to 1. So 0 to 1, 1 to 0. Likewise, it toggle. So it's a clock signal. Then initial, begin. So initially the clock signal value 0 and reset. So reset value also 0. So initially clock signal value 0 and reset value equal to 0. So after 5 time cycle, so reset value goes to 1. So initially reset value is set to be 0. So after 5 time cycle, this value goes to 1. Then after 20 time cycle, reset value goes to 0. So after 20 time cycle, this value goes to 0. Then I fix the time. So here deadline is 500. So 500 nanosecond or picosecond. So 500. Finish the count. So finish the count on 8. So in this particular lines, first you fix clock value 0 and reset value 0. Then after 5 time cycle, reset value goes to 1. After 20, reset value goes to 0. Then 500 is a deadline for counting purpose. Then going to monitor the result. Initial, then begin. So del monitor. So this command is called to monitor the result. So del time. So here first one is clock. So clock equal to percentage of 1B. Then second signal reset, percentage of 1B. Then Q So Q is a 4-bit value, percentage of 4 bit. Then clock, reset and Q. Then close the module. So begin and end. And final instruction is end module. So first you write the module name, then declaring the input variable and output variable. So input variable declare as a register and output variable declare as a wire. Then declaring the instantiations. Then next you initialize the clock time cycle and reset time cycle and deadline of counting values, and finally monitor the output. I hope you understand the concept very well. If you are watching first time in my video, kindly subscribe and support us to make a lot of videos. Thanks for watching my channel. Thank you.